We are studying kinematics. Kinematics is a branch of mechanics. In mechanics, we study about rest and motion of bodies. In kinematics, we study about motion without reference to the forces causing the change in motion. So we are not going to talk about forces in kinematics. Now one question that we must understand very clearly is whether force is required to sustain motion. If a body is going at 2 meters per second in a straight line in free space where there are no forces, do we need to continuously apply force to that? We don't need to apply. Force is not required to sustain motion. That is what is Newton's first law. Force is not required to sustain motion as per Newton's first law. Okay, because everybody wants to continue to remain in a state of rest or state of uniform motion in a straight line unless it is compelled to change that state by an external unbalanced force. That is what is Newton's first law. So to sustain motion, we don't need force. Okay, we feel that for sustaining motion we need force because whenever something is moving, it comes to rest. But it's coming to rest because of some external force like friction, like air resistance. Okay, if there are no forces, the body would continue moving forever. Okay, no force is required to sustain motion. So then what for is force required? Force is required for change in motion. So force is required for change in motion. That is acceleration. Because force is related to acceleration. F equal to ma. Newton's second law. The most important equation in whole of physics. So force is mass into acceleration. Force is required for acceleration. Force is not required to sustain motion. Now what is the meaning of motion? A body is moving. Another body is at rest. What does it mean? Motion is the continuous change in position of an object. Continuous change in position of an object with respect to an observer. So we must define the observer first because there is nothing called absolute rest, absolute motion. So if a body is continuously changing position with respect to some observer, then we say the body is in motion. This observer is called reference frame. So observer is reference frame. Now, what is reference frame? It is observer, very good. But what is it? What is reference frame? Also known as frame of reference. In your notes, you can write this as short form F.O.R. So what is this reference frame? Reference frame is a coordinate system, x-axis, y-axis, z-axis, with respect to which a given motion is studied. WRT is with respect to, that is the standard short form. So it is a coordinate system with respect to which a given motion is studied. So we have x-axis, we have y-axis. Okay, let's forget the z-axis for the time being. The body is moving now in 2D space. And at the origin, we have the observer. Okay, right over there, don't draw this face there. But just to make you remember, help you remember, I am drawing this face here. So this is the origin. This is the x-axis. And this is the y-axis. And here is the observer. The observer is attached to the origin of the reference frame. And with respect to this x-axis and y-axis, the observer is studying the motion. Now, this observer sees a particle at some time here. So how can he tell the world the position of the particle? Suppose you can see the x-axis, y-axis, but you cannot see the particle A. So how will you tell where is the particle? He will tell, move at an angle of 30 degrees with the x-axis, travel for 10 centimeters, then he will find that particle. So this kind of position, he can tell with the help of what we call position vector, RA vector. Position vector. Position vector is a vector joining the origin of the reference frame to the position of the particle. That is what is position vector. Position vector is a vector joining the origin of the reference frame to the position of the particle, and that we can write as R subscript A, so to show that it's position vector of particle A or position A, and we put arrow on top. So RA vector is the position vector of A. Now this particle is moving. So after some time, the particle moves to a new position B, whose position vector is RB vector. So this is the new position vector. Particle will travel along some path. So particle goes like this as it goes from A to B. So this you can call it path, P-A-T-H. And if you want to scare people, you call it trajectory. Trajectory actually means path. And as the particle goes from A to B, it travels some distance. So distance traveled, which is a scalar, is length of actual path covered by the particle. So length of this path is distance traveled. And speed, which is also a scalar. Speed starts with S, scalar also starts with S. Speed is also a scalar, and speed is distance traveled per unit time. So distance traveled by time taken is what is speed. Speed is a scalar, distance traveled is a scalar.